Hello everyone. Let's start our next topic, that is path testing. We'll see the definition of path testing, example on the path testing. Next, what is program graph, how to draw the program graph, a program graph of a triangle program. Next, we'll see the DD path testing, how to draw the DD path graph, and few of the concepts. So basically, we'll start the definition of a path testing. A path testing is an imperative programming language. Its program graph is a directed graph in which nodes are either statements or statement fragments and edges represent flow of information or flow of control. So in the path testing, we mainly consider the nodes. Nodes are taken to be a statements or statement fragments, and edges between those two nodes are said to be a flow of information. So it is given in this example, if I and j are nodes in the program graph, if there is an edge from I to j, if the statement corresponding to node j can be executed immediately after the statement corresponding to node I. So when you are taking a node I and node j, if there is a directed edge between these two nodes, that is I and j, then j will be executed immediately after execution of the node I. So these are some of the example of different if different statements, that is conditional statements, that is if then else statement, looping constructs, switch statement. In that case, we'll come across such program graph. But before this, we'll see the what is program graph and a program graph of uh, triangle program. In the triangle program, we have seen the pseudocode of the triangle program. How to draw this program graph of a triangle program is, for this pseudocode, behind the statements, just write the line numbers for this. When you write the line numbers, those line numbers are nothing but a statements, and those are nothing but the nodes in the program graph. 4 to 6, 4 to 8. So from fourth line to the eighth line. So these are the sequential flow of execution. Node 9 or line number line is a decision making node. That is, when you come across a decision making node, we have two paths. One is a true path, another one is a false path. Similarly, 13, 14, 16 are again a decision making node. When we have a decision making node, always it will be having a more than one path. So it may be a we may have two paths. One is a true path, another one is a false path. So if you are considering an example of a triangle program, here we have a pseudocode of a triangle program and a corresponding program graph of a triangle program. And next, if this concept is clear, then I can switch from a program graph to the DD path graph. So when you the DD path graph, to see the DD path graph, we'll have to first see the concept of or the definition of a DD path. What is DD path? And again we have a graph on the DD path graph. Again we have a graph called as a DD path graph. Here the term DD, it stands for decision to decision path. We have 5 cases in this. A DD path is a sequence of nodes in a program graph such that it consists of a single node with in degree 0. This is the case number 1. And second, it consists of a single node with out degree 0. This is the second case. It consists of a single node with in degree greater than or equal to 2, or out degree also greater than or equal to 2. Fourth case, it consists of a single node with in degree is equal to 1 and out degree is equal to 1. It is a maximum chain of length greater than or equal to 1. Chain means the connectivity from the first node till the last node. It will be greater than or equal to 1. So to explain this all the cases, in degree 0 and out degree 0. To explain this one, we'll have to go to the again program graph. where we have this in degree and out degree 0. If you see the first statement or first node, that is 4, its in degree is 0, but its out degree is 1. So which is that node wherein the in degree is 1 and out degree is also 1. If you consider the node number 5, its in degree is 1 and its out degree is also 1. So we also know in some of the case wherein the in degree and out degree of a node will be greater than or equal to 2. So which is that case here in our program graph is in degree is equal to 2 and out degree is equal to 2. So which is that node which is having in degree is equal to 2. You can see the node number 12. Its in degree is 2 and but its out degree is 1. So which is that node which has an out degree as 2. If you see the node number 13, it has out degree 2. And if you see the node number 14, it has out degree 2. If you see node number 16, its out degree is 2. And what is the conclusion of this is, whenever you have a decision making node, always you'll be having two paths. One will be a true path, another one will be a false path. So the same thing, by considering that concept, or the whatever the uh, definition of the DD path what we have seen, so those four cases are reflecting in the DD path graph of a triangle program. We have seen the program graph over here. How to convert this program graph to the DD path graph is, okay, rather than writing the line numbers, it is written with the characters, or for that we call it as a DD path. So here the node numbers 5 to 8 is written with a letter that is A, and 4 is with the fourth node represents first over here, okay, and ninth node with B, and similarly 13th node is represented as F in the DD path graph of a triangle problem or triangle program, and the 23rd node is represented as last. So here, if you see, if you compare the program graph with the DD path graph, if B means node number 9, F means node number 13, and H means 14, J means 16, L means 18. So in this way, if at all we know the concept of a program graph, one can easily write the DD path graph also. And what is this last column? Case of definition. Case of definition means these are the different cases which is being shown here. That is, first case, that is in degree is equal to 0. It consists of a single node with in degree is equal to 0. So that case definitions are written over here. So what is this H with 3? H with H case, H node is having case 3, it seems. Well, check it out. Case 3, yes. It consists of a single node with in degree or out degree 2. H is 14. 14 has, yes, 14 has out degree 2. So this third column will give you the case definitions what we have studied in the definition of the DD path. Coming to the next slide. Okay. DD path testing. Our ultimate aim in the path testing is to test each and every uh, statement at least once. So DD path testing means when you come across a path concept, there will be several paths in the program graph. Why several paths in the program graph? Because many if conditions will be there, many loops may be present in the program. So depending on the conditions, the path changes. When you give certain input, at that time, based upon the input or in our program, that is a triangle program, to calculate whether or to know whether that input whatever you have given can form a triangle or not, we will have to check whether it forms a triangle. If at all I give 5 5 5, then definitely my path should be across an equilateral triangle. So what DD path testing says that it should be traversed in the program graph at least once. So for that we call it as a DD path testing. And we'll have many loops also. For that we say that a simple loop coverage. If we have a loop, so if at all in while testing, if we cover the loop, then it is called as a simple loop coverage. In the loop, many times we come across a for loop, while loop, and a do while loop. In the for loop initialization, testing, and incrementation. In the while loop, the first condition will be tested, and if it is true, then the loop continues. If it is false, and when if it is false, then that loop will not be executed. Next, in the do while loop, without testing the condition, at least once the loop gets executed. If the condition is true, once again it will execute, otherwise it comes out of the loop. Predicate outcome testing. This level of testing requires that every output of the decision must be executed. Every every outcome of the decision must be executed. So whether it is a true or whether it is a false. So both these scenarios has to be executed. Suppose if in my program only one if statement is there, if statement has two possibilities. One is a true possibility and another one is a false one. So both has to be tested. So complex loop coverage. In the complex loop coverage, we'll be having concatenated, nested, and a knotted. Concatenated means loops connecting each other. In the first one, this is the first one which shows a concatenated, that is first loop continued with a one more loop. So two loops are connected here, and second one, the loop consisting of one more loop. So this is called as a nested one. One loop nesting another one. So this is the next one is a knotted one. In the knotted one, here the condition is tested, and here in the node number C, in the node C, the condition is tested. If it is true, once again the loop repeats, and in the D, that condition is tested. If it is true, again the loop will be repeated. So this type of scenario is called as a knotted loop. Next, what is basis path testing? Mathematically, usually define a basis in terms of a structure called a vector space, which is a set of elements as well as operations that correspond to multiplication and addition defined for the vectors. Basis path testing mainly it is proposed by the MACAPS. His name is MACAPS, and what is basis path testing is always a basis path testing is given by a formula V of G is equal to E minus N plus 2P. So what is considered here is it is a directed graph that we might take to be the program graph. Here also a program graph is taken for calculating the MACAPS or cyclomatic complexity. We can always create a strongly connected graph by adding an edge from the sink to the source node. Here one thing to understand is which is a sink node and which is the source node. Source node, that is a starting or a first node, is called as a source node, and the last node is called as a sink node. One confusion arises in this MACAPS basis path testing is we have two formulas. One is V of G. The V of G is equal to E minus N plus 2P, and V of G is equal to E minus N plus P. And what is this E, N, and P? E is the number of edges in the program graph, N is the number of nodes in the program graph, and P is the number of regions. By taking an